So if I asked you to find the limit as x approaches 0 of x squared cosine of 3 over x plus 2. Okay, can we all agree that we couldn't just plug in 0 here? Okay, in the argument we see that's dividing by 0, so we couldn't just plug it in and get it. What is the first statement we should always have on the squeeze theorem? Less than or equal to sine or cosine, depending on your function of x. Okay. Then the second step, we are trying to build this, so I need to make my angle match. And it's true for both sine and cosine that regardless of the angle, the argument or the high and low points don't change. So I can just change that to 3 over x. What would be the next step in this? We've got all this. Next we need the x squared. So we're going to take everything times x squared. Okay, so now I have all this. What do I need next? Plus 2. So we add 2 on each piece. Right, remember your answer is the work, so you can't just jump from the first statement to the final one. We're doing one thing at a time. Drop my plus 2. Okay, is everybody with me here? So looking back, what's the next thing we need? Add the limit to all those pieces. Okay. The whole point is that we can't do this limit in the middle. But on the ends, these are polynomials, so I can plug in my 0. So if I put in 0 for this one, we get 2. If I put in 0 for this one, we get 2. So that tells me my overall limit is 2. All right. So you know 10 questions, one of them is a graph, one of them is a squeeze theorem. There will be one question kind of going back to the original thing. So remember we started out finding limits from tables of values. Obviously without a calculator I can't really have you make a whole table of values, so I might give you a table and ask you what is it approaching. But we talked about average versus instantaneous velocity. So let's say I gave you equation. So we'll do a velocity equation. So I can ask average and instantaneous. All right. So if I said find the average velocity between 1 second and 2 seconds. Average velocity is the same thing as what? Slope. Remember when we made those tables, we basically found the average velocity over and over again. Instantaneous was what that approached. So if I'm asking you to find the average velocity, we basically need 2 points. I gave you your x, or your t values in this case. How would I get my y? So we get 80 minus 16, or 16 plug in a 2. I get 160 minus 64 or 96. So then average velocity is the slope between those. y2 minus y1 over x2 minus x1. So my velocity, I probably should have given you some, I said the time was in seconds. My equation I should have told you was in feet. So that's my average velocity. And then if I asked for instantaneous, I would have to give you a table of values and ask you what it's approaching. All right, can we handle that? So one of your questions is like that. That's kind of going back to the very first section in this. Since then, we've really just been doing limits. So that leaves lots of problems here. So let's kind of talk about your review, all the different strategies. So number 1, or number 2 on this. Let's talk about that one. We have the limit as x approaches 0, square root of 1 plus x minus 1 over x. So you'll have a problem involving a radical. What is our strategy when we have radicals? Conjugate. So the conjugate is you take the piece with the radical and you multiply, same thing but opposite sign in the middle. All right, remember you write the limit up until the step when you plug it in. So if we FOIL those, we get 1 plus x minus 1. I'm not going to FOIL on the bottom because I need that x to cancel out. That's the piece that's making it undefined. So then what happens? The 1's cancel. So we get x over this. And then what happens? X's can drop out. And now we no longer have a problem. So once you have the point where you're not getting 0 on the bottom, you can plug in and we get 1/2. All right, so if I give you a problem where you have to multiply by a conjugate, that's okay? There are lots of factoring and reducing problems on this, so you could probably expect a couple of those. So, you know, like question number 3, question number, I don't know, there's probably another one for you, factor and reduce. Number 9, number 15. So all of those where you have to factor things and reduce first before you can plug in your limit. So we'll have probably a couple of those on our quiz. We have some where we can just plug in, like number 4, it's not giving us 0 on the bottom, you could just plug in. Number 14, there's no fraction at all, so we could just plug in and evaluate, so we could handle that. Let's talk about something where we had to get a common denominator. We had a couple of those on this review. So questions 6 and 7. Would you like for me to work one of those over the other?
7.
So we check, we can't just plug in because we're getting a 0 on the bottom. So we have to get a common denominator. So we can put these together into one fraction. This one has a denominator of 2 plus x, this one has 2. We need them to match. So this one needs 2 on top and bottom. This one needs 2 plus x on top and bottom. So we would get x over 2 times 2 plus x, or you could distribute that if you wanted, minus 2 plus x over 2 times 2 plus x. What would I do with this negative? Once you have a common denominator, we can put those together. So positive 2 and negative 2 cancel. So that gives me a negative x over 2 times 2 plus x. Are we okay there? Now, like on question number 6, once you put it together, things canceled out and we were pretty well done. This one's a little bit uglier. It has an extra step because we have the fraction and a fraction. How do we divide fractions? So this top is like x over 1, so we'd have x over 1 times 2 times 2 plus x over negative x. Technically, you could go ahead and plug in right now because you're not getting 0 on the bottom. You could cancel these x's first. It's not going to matter. If we plug in there, we have 2 plus negative 2 divided by negative 1. So we get 0 over negative 1 or just 0. So have to be able to get a common denominator on 1. Trying to look at all the different strategies. So there's several more multiplying by a conjugate problems on here. The only one we haven't really talked about would be something like problem number 10. I'm going to look at that one.
Yes.
Can I just plug in from the beginning?
No.
No. Do we have anything we need to get a common denominator for? No. Do we have anything that factors and cancels easily? No. Do we have a radical where we need to multiply by a conjugate? No. So our only other option is really to start multiplying this out. If I have x minus 3 cubed, that means we have 3 of them, so we're going to multiply. Multiply 2 at a time. So if I multiply those, we get x squared minus 6x plus 9 times x minus 3. Alright, now I'm going to take my x to each of those. So I get x cubed minus 6x squared plus 9x. Distribute the negative 3 to each of them. So negative 3x squared plus 18x minus 27. So that gives me an x cubed minus 9x squared plus 27x minus 27. And we still have that plus 27 on the end. So all I did is I took this, multiplied it out, and got it here. What happens? Then I have x cubed minus 9x squared plus 27x over x. Everything has an x, so if you take an x out of each term, we have x squared minus 9x plus 27. Now there's no longer an x on the bottom, so we can plug in. So we get 0 minus 0 plus 27. So sometimes we just have to multiply it all out to simplify. Questions? Yes?
On the question number 13,
All right, let's look at it.
I don't know if we did it on two or not.
So 13. What would be our strategy on this problem? Conjugate. Okay, so right now it's this x minus 3 that's giving me problems because it gives me a 0. We have radicals, so we'll multiply by the conjugate. So on the top, if we distribute, radical x times radical x would just be a plain x. Plus radical 3x and minus radical 3x cancel. Minus radical 3 times radical 3 is 3. Everybody with me there? On the bottom, I am not going to distribute because that x minus 3 is giving me a 0 and I need it to cancel out. And now it does. So we have the limit as x approaches 3 of 1 over square root of x plus square root of 3. So now we can just plug in the 3. So we get 1 over 2 radical 3. But it's not proper notation to leave a radical on the bottom. So I just multiply by radical 3 on top and bottom. So we get radical 3 over 6. Any others you want me to talk about?
Number 12.
Number 12. Okay. So fractions tell me I need common denominator, put them together. But if you notice, look at those two denominators. What's the difference? So if you have a subtraction, you can distribute the negative through the top or the bottom. If I take this through the bottom, then my denominators are the same. So I could just add these fractions together. So that gives me a 2x plus 16 over x plus 8. Now I still can't plug in, but what could I factor out of the top? That would give me a 2 times x plus 8 over x plus 8. So then those x plus 8's drop, and what's the limit of a constant? The constant. So we just get 2. You could have worked this out by getting a common denominator and multiplying the first one by negative x minus 8, second one by x plus 8. You would get there, it's just a little more work.